boys and gashes.
All right. So here's our question here. So the question is, in a data analytics project, you are given two data sets, right? So these are your data sets. So data set one can be analyzed using three methods, which is regression, clustering, and time series analysis, all right? So now data set two can be analyzed using four methods, right? Which is hypothesis, testing, correlation, classification, and anomaly detection. All right. So now the question here is using the fundamental principle of counting. Okay. Now it says calculate the total number of possible combinations of analysis methods for both data sets. All right. So now let's try to. So now remember, let's do a problem recap. Okay, so we'll have data, data set one, right? Data set one, okay, which could be analyzed in three methods. Okay, three methods, right? So, and these methods include regression, okay, also clustering, right? And also what else? And time series analysis, remember. Okay. Okay. Right. So again, we also have data set two, right? Which now needs to be analyzed using four methods. Okay. Which is hypothesis testing. Okay. What else? Correlation. Relation. Am I typing it? Okay. Yeah. So correlation, classification, classification. Right. And anomaly detection. And anomaly detection. Right. So now, remember, so now we're going to start with step one, right? Understanding the fundamental principle of counting. Right. So now remember that the fundamental principle of counting states that if there are n ways, right, to perform one event, right, and the m ways to perform another event, then the total number of outcomes for both events happening together is the product of n times m, right? So these are the ways. Okay. The ways, the n ways and the m ways. All right. So now we need to apply the principle now to data set one, which has three ways to analyze the data, and data set two, right, which has four ways to analyze the data. All right. So now we need to calculate the number of combinations. Okay. So let's calculate the number of combinations. So we'll have the total, right? Combinations, right? Based on the definition. Okay. So will then be equals to take this three times, remember, calculating the number of ways, right? Times four. Okay. Which will then give us a 12. Okay. So let me just expound on it a bit and explain. Okay. So now each analysis method for dataset one can be paired, right, for this data set can be paired with analysis method for data set 2. All right. So you have three choices for analyzing data set 1. Okay. Regression, right? Clustering and time series analysis. All right. And then for data set 2, you have four choices for analyzing this one. All right. So you have hypothesis testing, correlation, classification, and anomaly detection. All right. So thus there are 12, right, possible combinations, okay, of analysis methods. Okay, combining one method from dataset 1, okay, and dataset 2. Okay, so this approach is a practical application of the fundamental principle of counting. Remember, so this is a fundamental principle. So this is what we were applying. Principle of counting. All right. So yeah. So now this is often used in data analysis to determine the number of ways you can combine or apply different techniques to multiply data sets. So yeah, there you have it. Thank you.